Hey guys, welcome back to a new video, and in this video we want to discuss one of the most important flow that we can use to communicate from one coroutine to another coroutine. It acts like a walkie-talkie for our coroutine and we call it channels. Let's get started with our video and try to deep dive in it with proper examples. So for that, I'm going to create here a main function and I'm going to launch a coroutine with the help of run blocking. So in order to create a channel, just use here a variable naming channel and initialize this thing with channel. Mention the type that you're gonna send from one coroutine to other coroutine as an information. Now in this channel constructor, if you notice, we have three things. We have capacity represents the buffer size. Next we have on buffer flow. On buffer flow will decide the behavior, what will happen if our buffer got full. And lastly the on undelivered element. So suppose in any case your buffer got full and it just drop few values, this value you can receive within your on undelivered element. It's time to launch a new coroutine because as I said to you, this is used to perform communication from one coroutine to another coroutine. So this is our first coroutine and we're gonna repeat a loop 10 times. Print one statement which says emitting the value and use channel send to send the information. Okay, so we just send the information. Now it's time to receive it. So as I said to you, channel is used to communicate from one coroutine to another coroutine. Let's launch one more coroutine. So it's a new coroutine and in this we'll create a for loop and we'll simply iterate all of the values that we have within our channel, and at the end we simply print it. This is my one coroutine, this is my next coroutine, and we want to send information from this coroutine to this coroutine, I mean the different coroutine. And this is a perfect place to use channel because the sole purpose of channel is to send information from one coroutine to another coroutine. Alright, so execute it. And you can see emitting value, received value 0, emitting 1, emitting 2, received 1, received 2. So basically you will receive all of the information that we were sending from first coroutine to the second. So now it's time to discuss all of these parameters that we have. So first we have capacity. So initially capacity is 0, that means buffer size is 0. If you send information more quickly and your collector can receive the value a little bit slower, your stream that is used to send the information will be suspended for the time being, and once the collector receive all of the information, or you can say the receiver can receive all of the information, it simply resume the execution of your producer stream and produce the value, and collector or you can say receiver can receive the value. This is how it works, and this behavior is by default because by default it uses buffer overflow dot suspend, and this is how suspend buffer overflow strategy will work. We want to use here different capacity. Let's say I want to here capacity 3. Next, let's talk about the buffer overflow. So buffer overflow is used to decide what will be the behavior if our buffer got full. So we'll use here on buffer overflow. Buffer overflow we have 3: suspend, drop latest, and drop oldest. So let's use suspend for the time being, and on undelivered element will deliver you the undelivered element. I'm gonna print the undelivered element. In order to show you how buffer overflow will work, I'm gonna produce here a delay in consumption. So delay of let's say 500 millisecond. So in this scenario, our channel send information very quickly, but our collector receive it very slowly. So this will surely full our buffer for the time being, and we will see how buffer overflow will react on that case. So let's execute this function. So capacity is 3. Alright, so this is our execution, and in this execution we are emitting values and the receiver can receive the values, and in this scenario there will be no element or you can say value lost because we are suspending the producer stream once the buffer got full. There is no reason that we should not get the values correctly. But what will happen if I use the another buffer overflows like drop oldest? So let's use it and execute this function. You will see the clear-cut difference. Alright, so here you can see it emits value from 0 to 3. Undelivered element is 0 when it try to emit the value 4 because buffer capacity is only 3. Next, undelivered element will become 1 when it try to emit the value 5. Similarly, the cycle is going on. and at the end we receive the 7, 8, 9, because here we say that drop the oldest value. That means in the buffer, if you check out in here 0, 1, 2, 3, what will be the oldest value is 0, and that's why it undeliver this 0 and put 4 in this place. All right, now if I just change this drop latest and execute it, this time it will undeliver the third one. Now in this case, if you notice the difference, it emits value 0, 1, 2, 3, but as soon as it try to emits 4, it undeliver this 3, because this time we say that drop the latest element, not the oldest one. And if you check out the receiver, it receives 0, 1, 2, because we are dropping the latest. That means in the buffer we only left with the oldest value, which is 0, 1, 2. Now I think the logic is clear, and also why we use this on undeliver element and why we use on buffer overflow. Okay, so let's back to the normal, and we have here few more ways to pass this capacity. So channel dot unlimited means unlimited memory, and I prefer never use unlimited, because somehow you are tending to use unlimited memory, which is not a optimal way of using channels. So never use this unlimited. Next we have buffered uses the by default capacity, which is 64. Next we have conflated says that only receive the latest value. Remove this delay and execute it. See, it emitted a lot of value like 0, 1, undeliver 0, emitting to undeliver 1. So basically at the end you will only receive the latest value, which is 9. So this is how it works. Now let's see how we can use multiple senders to send information on the same channel. So for that, I want to launch a new coroutine, repeat loop for 10 times, print ln, and this time I'm saying emitting second and the value, and at the end use simply channel send the information. This time I want to multiply this thing with 2. So this is my second sender that sends the information to the channel. Okay, remove this conflated and just remove everything. Execute it. So here you can see in the log, it emits value, second also emitting value, and receiver received all of the information, and at the end you will get the multiple of those. So this is how you can use same channel with multiple producer who can produce values, and consumer can consume it or receiver can receive it. So producer and consumer means sender and receiver, okay, respectively. Next we're going to discuss ticker. Ticker is used when you want to execute a loop after a fixed time interval. So for that, let's create a variable naming ticker and initialize this ticker with the help of ticker. You need to pass the delay, and initial delay is 0. We have also mode here, and in this you can pass your mode. So basically we have only two modes, fixed period and fixed delay. I want to use here fixed period. Next, just create a loop element within our ticker, and in this I want to use my ticker and receive its value, and at the top I want to create here a counter. Initial value is 0, and in this just use print ln to print the value. So tick mention the counter incremented by 1, and that's it. Let me remove all of the things from here, and now I want to execute it. Okay, see, 0 after 1 second will receive 1, then 2, 3, 4, 5, 6. Similarly it goes on. So if you want this kind of behavior, you can use this ticker function, and this ticker function will eventually give us a channel. Alright, so that's it for this video. I hope you like this video. If you do so, please subscribe my channel and also write your precious comment. That's it. We will meet in our next video. Till that, goodbye.